Okay, so just like last time, uh, here's a problem. We could do 3x minus 4 times 2x minus 3. Why don't you just quickly work it out using the graphical method? I'll give you 3 seconds. Okay, so first of all, notice which ones are positive, which ones are negative. Positive times positive is positive, and then negative times negative is also positive, and whenever you have positive times negatives, those ones will be left white or negative, in other words. So you add all those up, and you get 6x squared minus 17x plus 12. But is there a better way of doing it without doing all of the drawing? And so I'm going to just quickly show you the previous way we did with the double digit multiplication as well. It'll be a bit of a hint for us here. So look at this here. Okay, so this is the rectangular problem we had last in the very first video rather. And so the first big area I'm going to do is going to be 30 times 20, so that's going to be 600. Okay, in other words, I'm doing 30 times 20. Over to the right here, this is going to be 30 times 3, that's going to be 90. Or in other words, 30 times 3. Down here in the bottom is going to be 20 times 4, that's going to be 80. Okay, so 4 times 20. And then the bottom right here is going to be 4 times 3, and this is going to be 12. So 4 times 3. And that's the same thing that's going to work with our polynomials as well, the same way of doing things. So if we redo this problem on the left of 3x minus 4 times 2x minus 3, using the same kind of methodology. Take the first number here, multiply it by each number inside the brackets. Then do the same thing with the second number. Okay? Let me show you what I mean. So we're going to take this first term, 3x, multiply by 2x. Well, that is 6x squared. Okay? And then we're going to take that same first number and multiply it by the second digit, which is, or the second term, which is negative 3. So 3x minus, sorry, 3x times negative 3 is minus 9x. Now use the second term, which is a negative 4. Negative 4 times 2x is negative 8x. And then negative 4 times negative 3 is positive 12. And when you collect those middle two like terms, you get 6x squared minus 17x plus 12. The exact same thing we did with the graphical solution. So this method works as well and can be extended to larger problems too. So let's just try one example like this, and then let's try a larger problem. Okay, so x minus 7 times 2x plus 3. Without using the graphical method this time, you're going to do the same process. In other words, take the first term, the x, multiply it by both terms in the second set of brackets, then do the same process for the negative 7, and then add up everything together. So go ahead and do that now, and then I'll show you the answer in 3 seconds. Okay, so I've kind of done it in two different colors here. You can see what happened. So that x times the 2x is 2x squared, and then the x times the positive 3 is positive 3x. And then negative 7 times 2x is negative 14x. Negative 7 times positive 3 is negative 21. And when you combine all your like terms, you get 2x squared minus 11x minus 21. And that's the correct answer. Okay, so now what happens though, providing you did that one okay, what happens when you start multiplying binomials by trinomials? It's the same process. In other words, you're multiplying every term in the first polynomial by every term in the second one. Okay, so in other words, you're going to take this x right here, multiply it by the 2x squared, multiply it by the negative x, multiply it by the positive 4. And then repeat the same process with the negative 1. So why don't you go ahead and apply that methodology and see if you can't come up with the correct answer. I'm going to reveal it in 3 seconds. Okay, well you'll notice that I didn't try to do this one graphically because it gets a little tricky trying to get cubes, trying to draw a two-dimensional cube. So in any case, there's the answer there after you collect like terms. Go ahead and follow through if you need to closely examine the order I did those in. But that's basically it, okay? And so when we get back in class on Monday morning, we will go over all this again and get a chance to do it in real life, in class, on Monday. You all have a great long weekend if you haven't had one already, and we'll see you Monday.